Hi guys, Mr. Robeson here. We are going to look at finding mean and standard deviation today from discrete probability distributions. All right, so mean or expected value. So mean and expected value are the same thing, so don't forget that. So we use different symbols for them, but they do mean the same thing. So we have mean and we have expected value, E of X. They do mean the same thing. That is a capital E. I know it doesn't look like it. E of X, expected value. All right, when analyzing discrete random variables, we follow the same strategy. So like if we're asked to describe a distribution for a probability distribution, we're still going to talk about shape, center, spread, identify any outliers. We're probably not going to have outliers for these sort of things. We're still going to include context, don't forget to BS. But when we do the center, we're probably going to use the mean here or the expected value. All right, they are the same thing. We'll use standard deviation most likely for spread. Shape could be symmetric, could be normal, could be skewed. It's up to the graph, really. So the mean of any discrete random variable is an average of the possible outcomes, with each outcome weighted by its probability. So in other words, it's just a weighted mean. So x values are our x's, and our p's are our weights. Right? And that gives us this. The mean for the probability distribution of the letter x, or is equal to the expected value, is just equal to each one of the x values times its p's. So we're just summing up each x value times its probability. All right, so the mean is equal to the mean of the x is the sum of the x times the p. All right, usually we would divide by the total sum of the weights, but the total of all the probabilities is always 1. So we're really just dividing by 1, so we can just leave it out. All right, so some examples. We've got a practice AP statistics exam, and we got each of these scores, 1 through 5, and we got the probability of getting each score. So if we want to find the mean, so the mean score would equal 1 times 0.10 plus 2 times 0.18 plus 3 times 0.42 plus, I'm running out of room here, 4 times 0.24 plus 5 times 0.06. And I believe if we multiply each one of those and add them up, we get 2.98. Right? And that is also the expected value of x. That would be the expected score, about a 3 out of these people. And it makes sense because 3 looks like it's got the highest probability and it is in the middle. So that all kind of makes sense. Like if you got an answer like 6, you probably did something wrong, right? Because the scores only go from 1 to 5, and most of them are in the middle here. All right, let's take a look at another example. I'll change colors so we don't get confused here. The school has a raffle as a fundraiser. They sell raffle tickets for $2 each. They sell a total of 1,000 raffle tickets. The prizes are one TV worth $600 and one tablet worth $500. What is the expected value of the winnings for someone who buys one raffle ticket? All right, so we need to figure out what our x's are and what our probabilities are. All right, so when we're talking about our x's, we're talking about the winnings. How much are they going to win? And I'm going to go down with my table here. I'm going to go up and down, horizontal, or sorry, vertical instead of horizontal. And then we've got the probability for each one. The prob. All right, so one thing that can happen is we could win a TV. It's worth $600, but don't forget we paid $2 to play. So we're actually going to get 600 minus 2 is $598. Next thing that could happen is we could win the tablet. So it'd be 500 minus the $2 that we paid to play, so it'd be $498. The other thing that could happen is we don't win. All right? And if we don't win, we still paid $2 to play. So we're down $2. So one person out of 1,000 wins the TV. One person out of 1,000 wins the tablet. Everybody else, 998 people out of 1,000, lose $2. So I'm just going to add in this extra column, x times p. So we're multiplying across here. This times this equals 598 over 1,000. This times this equals 498 out of 1,000. And this times this equals negative 0.1996 out of 1,000. All right, now we just want to add all those up. Let's see if I can bring up my calculator. I haven't done it already ahead of time. So let's see. We've got 598. We already have a common denominator, so we don't have to worry about that. Plus 498, and then minus 1996 gives us a total of negative 900 out of 1,000 is what we're going to get. So the total here is negative 900 out of 1,000. This is actually our expected winnings, or our mean. All right, or if we want to write that as a decimal, this would be negative 90 cents. So we would expect to lose 90 cents per play, which makes sense because they want to make money from the raffle, right? They're using it as a fundraiser. If the winnings didn't end up being negative for the people playing it, then they wouldn't be making any money from it. And this is the same way casinos work. Every casino game has a negative expected value for the player. That's why they say the house always wins. All right, so here's another example. Find the expected value, just a generic probability distribution. So remember, we just got to multiply across here. So we got an x times p of x for each one. So it'd be 0 times 0.05 plus 1 times 0.13 plus 2 times 0.28 plus 3 times 0.14 plus 4 times 0.24, and finally 5 times 0.16. We could type that all into our calculator, and we will get, I believe it was 2.78. Let's see if I remember right. It is 2.78. Yay. So the mean here is 2.78. And again, often we write this little x here because it's the mean of these x values. So the mean of the x's, or is the same thing as the expected value of the x, is 2.87. Standard deviation. All right, so we can also calculate standard deviation of this distribution like this of the x values. All right, and what we do first is we actually calculate the variance. We calculate the standard deviation squared. And the way we do it is we take each x value, we subtract the mean, then we square that difference, just like we did before when we were doing standard deviation. We always square the deviations. And then we weight each one by its probability. So then we multiply each one by its probability. We add them all up. And then at the end, if we want to get the standard deviation, we just take the square root. So we would take the square root of this, and that would give us the standard deviation of our random variable x. All right, this is a good bit of work. There is a shortcut for this. And actually, there's a shortcut for finding the mean as well. So we can put the data into lists. So we're going to use our one variable stats again. We put the x values into a list, say L1. Put the probabilities into a different list, say L2. We go to our one variable stats. For our list, we put in our x values. For our frequency list, we put in our probabilities, and then we do calculate. If you're using the TI-83 or the Graph and Calc 83 app on your phone, you're going to choose your one variable stats. You're going to type in L1, comma, L2. You can close parentheses or not. I don't think it matters, and just press enter. All right, so let's try and do it on our calculator now. So here is my calculator again. So now I want to find the standard deviation of the AP scores. So I'm going to go to Stat, Edit. There's my list. I've already got them in. So I've got 1 through 5, 1 through 5, and then 0.1, 0.18, 0.42, 0.24, 0.06. So I'm going to leave that. I'm going to press Stat again. Go to Calc, one variable stats. I'm going to put L1, L2, calculate, and notice, so there's our mean, 2.98. Notice it does not give you a sample standard deviation. It only gives you a population standard deviation. The reason it does this is because your calculator knows you're working with a probability distribution. All right? It knows you're working with a population because these are all possible probabilities that you got. All right, so our standard deviation is 1.029. So we get our mean x is 2.98, and our standard deviation for our x is 1.0, what was it, 29? 29, yep. All right. Same thing over here. We can find the standard deviation for our tickets here. So remember we were looking at winnings as our x, and then we were looking at the probabilities of each of those x's. So we could win the TV, in which case we were up $598. We could win the tablet, in which case we were up $498. Or we could just buy a ticket and nothing else, which means we lose $2. This had a probability of 1 out of 1,000. This also had a probability of 1 out of 1,000. And this had a probability of 998 out of 1,000, all the rest of them. So let's put that into our calculator. So stat, move it out of the way here in case you're still copying. Edit, and we need another list, so there we go. So 598, 498, and -2. Notice the negative is down here at the bottom, not the minus sign. So there's our 3 possible values. Now we've got 1 out of 1,000, 1 divided by 1,000. You can type it in as a decimal, or you can type it in as a fraction. It's going to change it to a decimal. The other one again is 1 out of 1,000, 0.001. And the last one is 998 out of 1,000, which is going to give us one too many there. Give us 0.998. There we go. So now we're going to leave here. Press stat, go to calc, one variable stats. Now my winnings I put in L3, so I'm going to press second 3 to get L3. My probabilities I put in L4, so second 4. And there's that -0.9 we got before, and there's our standard deviation 24.67. So the mean of our winnings is -0.9, and the standard deviation is 24.0. What was it for? Oh, sorry, 67. 24.67. This is in dollars. This is also in dollars. And there we go. These over here, the units would be AP scores. But that's how we can find standard deviation and mean just using the calculator. Much faster. All right, so again, you can try this on your calculator. We'd put this in, say, L1. We'd put this in L2. And then we'd do our one variable stats with L1, comma, L2, depending on what you're using, or you just put L1 for your values and you put L2 for your frequencies. All right, press enter a couple times, and we get an answer 1.45, hopefully. All right, and it should also confirm that as your mean. And that's it for this stuff. So now we know how to find the mean and standard deviation of a probability distribution. Next time we'll look at continuous probability distributions.